The next and last video of Unit 3 deals with step and piecewise functions. The three major things that we need to make sure we understand and can convey clearly to the students are how to write function rules, graphing open versus closed points, and how to write and read domain restrictions. When we're graphing function rules, we need to make sure that we understand how to graph different styles of functions: linear function, quadratic, cubic, square root, any type of function that we might be given. We also need to be able to do the converse of that. We need to be able to write those rules if we're given the graph. I find here that the technology is a great assister for writing those functions, being able to calculate those regressions based on points on the graph. However, each and every function that you have to write has a different set of criteria in order to write that function from its graph. So this would take a little bit of time making sure they understand what the parent functions look like, how those parent functions are transformed in order to get the functions that we're going to be seeing on different graphs that aren't going to be just your basic parent function. When graphing the open versus closed points, this is something that these students should know how to do and have been doing for several years in their math. However, just to reiterate and make sure they understand, the open point deals with the greater than, less than, and something that's not equal to. The closed point is the greater than equal to, less than equal to, or just equals some value. This is something that they don't do a whole lot of consistently from year to year. It's a unit, it's a section, and then they move on just a little bit past that. So it's something that could be forgotten from grade to grade. So we just need to make sure that they understand what these mean when they're graphed. Domain restrictions, this here is going to reinforce the graphing and the reading of the open and closed points. Here you want to make sure that the students understand what they're graphing and the set of domain for each specific function rule in their step or piecewise function. We need to make sure that they understand how to represent the open and closed points with symbols and how to represent the symbols with open and closed points when they graph. When writing the step functions from a graph, you need to first make sure they understand what a step function is as compared to a piecewise function. A step function is a function that's comprised only of constant function rules. So the horizontal lines looks like a staircase or stair steps, therefore step function. They need to be able to write the function from a graph, and they need to also be able to graph a function from a function rule given to them. I'm just going to write the function rule from this graph because it's pretty straightforward how to go in the opposite direction. So first, the standard procedure is to start any step or piecewise function with this style of notation, and then we begin with our furthest to the left. So from here it looks like f of x equals 2. Here it looks like f of x equals 3, 4, and then I'm going to make a leap and say that that's 6. And then we have to write our domain restrictions. The domain restrictions are if x is between 1 and 3 in this case. So here, if x is from 1 to 3, notice the difference between the open and closed circle, also the symbol with the equal sign and without the equal sign. And it follows pretty straightforward how to do this for every single piece of this function. So here this goes from 3 to 5, from 5 to 7, and then this one looks like it's from 7 to 11. One thing you'll want to make sure that they understand is whenever the points are located directly above or below one another, the open closed points on the same x value, they need to make sure that their domain restrictions begin and end at that same value. So This first one ends at 3 and the next one begins at 3. So they have some continuity in their graph to their domain restrictions. This graph here we have as a piecewise function. One thing I want you to notice is that there is one constant function in this piecewise function. The reason why it's not called a step function is because there's only one. Everything else is pieces of other function rules that we have. In this case, we have a quadratic piece, a linear piece, constant function, and then this is a square root style function. So writing the function rules, again, we start with the notation where we have f of x, and then we're going to have 4 function rules that we need to write. I made these all pretty basic, so it's easy to write the function rules really quickly for the sake of the video, but I also made them pretty basic so they could, if they wanted to, put them into their calculator and calculate the regression based on the points that are given. So right here we have the parent function. This is actually the parent function for the quadratic, but it's just from 0 to 2. So this is f of x equals x squared if x goes from 0 to 2. And then we have this linear function. This linear function looks like it goes down 1 over 1, down 1 over 1. So the slope here is -1. I don't have to put that -1x there, but I like to do that for some of those students who need that visual cue. And then the y-intercept, if we were to go backwards, so up 1 over 1 is +5. And this is if x is between 2 and 4. Notice the open circle here at 4. The next function here, this looks like a function value. Since this was down 1 over 1, down 1 over 1, this is at a function value of 2. If x is from 4 to 7, and notice here 4 and 7 are both open circles. So this function is not defined at the point of x equals 4. And then next we have the square root function. The square root function looks like it's going to be, it's the parent function, it's only shifted over 7 and up 3. So this, I believe, is x minus 7 and then plus 3. X minus 7 under the radical, plus 3 outside of the radical. This here is if x goes from 7 all the way to infinity. So this is if x is greater than or equal to 7. And that's step and piecewise functions in this video. Again, I just stressed on reading the graph and writing the function rule, but you do want to make sure that they can go backwards from a function rule, provide the graph.